Hi everyone, in today's lesson we're going to talk about the rational zero test. The rational zero test relates the possible rational zeros of a polynomial with integer coefficients to the leading coefficient and to the constant term of the polynomial. So if we have a polynomial, any polynomial in any general form, that has integer coefficients, every rational zero of f of x has the form p over q, where p and q have no common factors other than 1. So P is the factors of the constant. And Q are the factors of the numerator, of the leading coefficient. And remember, a leading coefficient is the number in front of the highest degree. So in other words, when I want to find all of the possible rational zeros, we're going to find the factors of the constant and divide it by all the factors of the leading coefficient. So let's put this into play and do an example how it'll be asked on the exam. So use the rational zero test to find the zeros of this function. Now, some of you are probably thinking, well, why can't I just factor this and t-chart it and solve? So let's see. Since it has 4 terms, we would try grouping. So I'll group the first 2 terms and the second 2. Take out an x squared. I'll be left with 2x plus 3. Take out a negative 1, and I'll be left with 8x minus 3. So what happens is that the inside of the parentheses are actually not the same. So that means we can't factor this thing. So there has to be another way to find the zeros. So let's use the rational root test. So we're going to find the factors of the constant, which is this guy. This is the constant. So all of the factors of 3 divided by all of the factors of the leading coefficient, all of the factors of 2. So we're going to divide those. So all the factors of 3 are 1 and 3. And the factors of 2 are 1 and 2. But you also have to remember and keep in mind that we could have positive and negative factors. So we always want to have plus or minus 1, plus or minus 3, plus or minus 1, plus or minus 2. And then we're actually going to simplify this. So what we're going to do is we're going to divide 1 by 1 and 1 by 2. So 1 divided by 1 is 1. So that's one factor, plus or minus 1. And then we're going to do 1 divided by 2. So the other factor is plus or minus a half. Okay, now we'll do the same thing with the 3. We're going to do 3 divided by 1, which is 3. So plus or minus 3. And then the last one will be 3 divided by 2, which is 3 halves. So the last factor is plus or minus 3 halves. So these right here are all of the rational zeros, all the possible rational zeros. So we need to figure out which one of these are actually a root. So I always like to test the whole numbers first because we can use synthetic division if it's a whole number. So I'm going to try a factor of 3 or a root of 3. So let's try this guy over here. So by synthetic division, I'm going to try 3 and I'm going to see if it's a factor. So again, we use the coefficients 2, 3, 8, and 3. So 2, 3, negative 8, and 3. And I'm going to try the root of 3 and see if it works. So bring down, multiply the 3 and the 2, which gives me 6, add, multiply, and then multiply again, All right, so we have a remainder of 60. So we know that if 3 is the root, then x minus 3 is not a factor. So now we're going to try another root. So I'm going to try x equals 1 now, and I'm going to see what happens. So if I try 1, I get 2, 3, negative 8, 3. Bring down the 2, multiply, add, perfect. I got a root of a remainder of 0. So that means that x equals 1, remember this is the root, x equals 1 is a rational 0. So with that being said, I can factor this now, where these are the coefficients of the quotient. So this will become 2x squared plus 5x minus 3. So if I need to determine all of the other zeros, we first have to factor this thing. So if x equals 1 is the root, then x minus 1 is a factor. And by long division or synthetic division, we found that this was the other factor. So to find the other zeros, we're going to have to factor this completely and then t-chart and solve. So let's see if I can use guess and test here. I'll put a 2x and and an x. So 2x and an x. And I think if I put the factors of 3 in here, I'm going to put 3 here and 1 here. So 2x times 3 is 6x, and this is 1x, so I need 6 minus 1 to get me 5. So positive 6 minus 1. Okay, so those are the factors. Set it equal to 0, and we can find our roots. So x minus 1 equals 0. 2x minus 1 equals 0. X plus 3 equals 0. And just to finish this off, add 1 to both sides. Add 1 and divide by 2. And subtract 3. So these down here are my roots. And these are my factors. All right, let's see if we could try another example. Let's go to the back. Okay, so the question says, use the rational zero test to find the zeros of this function. So again, some of you are probably wondering, why can't we just factor this? So let's just see if we can. So we're going to make this, take out a GCF of 5, x squared, and I'll be left with 2x minus 3. Then I'll take out a negative 4, and I'll be left with 4x minus 3. So notice again how these numbers in the parentheses are not the same. So we're going to have to find another way to find the zeros. So again, use the rational zero test to find the zeros of this function. So the first thing that we're going to do is find the factors of the constant. So factors of 12 all over factors of the leading coefficient, factors of 10. Okay, so factors of 12 are, remember, always plus and minus. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. Let's erase this. Oh, no, I can't. Okay, so then plus or minus 12. All over 10. Plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. So all of these, I'm going to cross this out, all of these possible rational zeros, there is a lot of them. So we're going to do 1 over 1, 1 over 2, 1 over 5, 1 over 10. So the first one would be plus or minus 1, plus or minus a half, plus or minus 1/5, plus or minus 1/10. Okay, now we're going to start with 2. 2 over 1, 2 over 2, 2 over 5. So 2 over 1 is 2. So plus or minus 2. Now, 2 divided by 2, this one, 2 divided by 2 is 1, so I don't need that because I already have it. 2/5 we can put, so plus or minus 2/5, plus or minus 2/10, which reduces to 1/5, so I have that already. 3/1, so that's plus or minus 3. Then we have 3/2, so plus or minus 3/2. Then 3/5 and 3/10. Okay, now 4. 4/1. 4/2, which is 2, I have that. 4/5, 4/10, which is 2/5, which I already have. So we're going to do 4, so plus or minus 4, and plus or minus 4/5. And then 6, so plus or minus 6, plus or minus 6/5, and then plus or minus 3/5, which you already have, and then 12. So 12/1, so plus or minus 12. Plus or minus 12 divided by 2 is 6, I have that. 12 divided by 5 I don't have, so plus or minus 12/5. And then 12/10 is 6/5, which I have. Okay, so these are all of the rational zeros. So we're going to have to use synthetic division to see which one is going to be the rational root or rational zero. So we're always going to try the whole numbers first. So I don't know, let me try 3, for example. So let's see if 3 is a root. So we're going to put 10, -15, -16, and 12. So I'm going to bring down the 10, multiply, add, multiply, add, multiply, add. Okay, I did not get a remainder of 0, so 3 can't be a root. Let's try 2. Okay, so 10, -15, -16, and 12. Bring down, multiply, add, multiply, add, multiply, add. So I got a remainder of 0. So that must mean this whole thing is a factor. So 10x squared plus 5x minus 6. So again, if x equals 2 is a root, then x minus 2 is the factor, and the result of the synthetic division is the other factor. Okay, so now if we want to try to find the rest of these roots, we would try to factor this trinomial here a little bit more. Now I'm just going to save us the time of guess and test and let you know that this trinomial actually doesn't factor. So if it doesn't factor anymore, how could I determine the other zeros? Well, I know that if I do a t-chart right here, this will be x minus 2 equals 0. Add the 2 on both sides. So we know that we have one rational root of 2. But if this trinomial here is not factorable, the only type of roots that we're going to have are either imaginary roots or irrational roots. Irrational meaning with radicals. So how do I find the factors of a trinomial that can't be factored? Nothing other than the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So what I'd like you to do for homework, or to finish, would be to finish the quadratic formula. Oops, can't spell. Finish the quadratic formula for homework and get the other 2 roots and decide whether they're imaginary roots or irrational roots. All right, have a good night.